Welcome to the Science Behind Science Fiction. I'm Phil Winters, and I'm a fan of science fiction, TVs, movies, books. I'm also a fan of science. As an engineer and researcher, I like to apply science to science fiction and see just how the two combine. I've had the opportunity to make several presentations to the Saturday Scholars Program, and we're going to do the same kind of application of science to science fiction today on television and reach a wider audience. The three areas we're going to be talking about for science and science fiction are science as it applies to a science fiction episode, and also science fiction of the past and how it's led to the science fact of today, and finally the science fiction of today and will it be leading us to the science fact of tomorrow. That first example of science as it applies to science fiction, we're going to be using a clip from the Terminator 2 movie. In that movie, it's present-day United States, and there's several robots from the future that come back into our time, and they need to react in our world. One of those robots is made of a metal that can form at will. It becomes liquid at will and then reforms in a new shape. That robot gets exposed to a very cold environment, and it reacts accordingly just as you would expect it to in our own environment.
Don't stop! Go straight! Get the hell out of here! Get out of here! Let's go! Go! Go!
I think it's that one. I'm going to assume it is. Boy, I hate hunting for that red light. Responded just as we would expect him to. That mercury, or whatever metal he's made of, was exposed to negative 320 degrees, which is getting close to absolute zero, and it froze, and in fact became very brittle, just as we would expect it to. This video clip did a very good job of applying real science to science fiction. Sometimes that's not the case. In old comic books, Superman picks up a bus. Well, he'd rip the bumper off a bus if he tried to pick it up. It just isn't made that way. This clip did a very good job of actually taking science and applying it to science fiction. I had an opportunity to give an example of liquid nitrogen and how it affects things around us at a Saturday Scholars presentation. We'll see a clip of that, and then after that we'll see just what happens to that Mercury man when he's exposed to those temperatures. Now, like I said, this is extremely cold stuff. I'll be sure not to spill it on the front row there. And this is boiling here as it sits in this dewar, and it's going to boil when it comes out here, because the room temperature is so much warmer than it is. It is essentially like putting water on a stove that's sitting there at 300 degrees. And right now it's boiling, a little bit boiling out of that dewar. I'm sure you're familiar with that video clip. If you were to take the Mercury man He's frozen solid now, he's at negative 320 degrees, and shock that frozen solid system with a very rapid or very sharp impact, like a bullet. Then the whole thing would just shatter.
Hasta la vista, baby.
Mr. Spock.
Yes, Captain. We were there with the communicator, beep, and talking to people in the late 60s.
Enterprise.
Enterprise. Spock here. Kirk here.
Spock here, Captain. There seems to be I did have occasion a few days ago to be using my own portable cellular phone. Somebody saw me doing it and burst into laughter and said, there's Leonard Nimoy using the thing from Star Trek, the communicator, as a telephone.
Hi. As Leonard Nimoy was saying, in the original series, that was Spock who played, or Leonard Nimoy who played Spock. He had a communicator from 30 years ago in Star Trek, and now we have our flip phones, and they operate very much the same way, and that's an example of science fiction leading to today's science fact. In the Star Trek of today, they all wear a little communicator pin, and they tap it, and it becomes the communicator, and they talk on that. Well, if 30 years ago they were using the flip phones, 30 years from now, will we be using these to communicate? We'll have to wait around and find out. The communications and microcircuitry, things like that, are an easy thing to see a progression. Some of the other things in Star Trek are not nearly so obvious as to whether or not they'll be available to us in the near future. Some of those include the transporter and the replicator.
That's odd. Sensors read a humanoid presence in 15 Delta. Could be one of the project thermologists.
Not in 15 Delta.
Look for yourself.
All the inhabitants were supposed to be evacuated by now. Well, I better beam down there. Take a look around.
Ready to transport.
I won't be long.
Great distances in the blink of an eye, Heron. But this transporter is only the beginning.
Go on. I'm listening.
There is a ship filled with new technology. Devices that can make food, water, even weapons appear out of thin air.
Mr. Paris, evasive pattern Delta 4. Mr. Tuvok, return fire.
Firing phasers.
Bridge to Taurus, can you transport to Kote?
I'm matching the pattern buffer frequency to the Kazon dampening field.
Make it fast.
I've got a lock. Initiating transport.
Do you have him, B'Elanna?
I had him for a second, but they've remodulated the dampening field.
Can you compensate?
I'm trying, but I need more time.
We'll try to hold them off, but we don't have long. Mr. Tuvok, phasers to maximum. Let's give them a little distraction.
For a science fiction TV show, it's very easy to take a person and turn him into energy and take him somewhere else and then rematerialize him. Beaming somebody from one place to another is a very easy thing to do because of the special effects they have available. We have a method or a theory that we can use to indicate how that could be done. Einstein had predicted or had given us an equation. His theory of relativity talks about E equals mc squared. Energy is equal to the product of mass times the speed of light squared. Now that gives us an idea of how much energy would be required to make an amount of mass. What they're doing with a transporter is taking mass, turning it into energy, and putting it back together. Now, putting it back together is beyond our technology. We can take mass and turn it into energy, and we've done that with atomic bombs, nuclear bombs. We're not able to take energy and just form mass with it. That's what they do in Star Trek with replicators. Those replicators will take energy, form it into something, and then you can use that substance. For instance, one of the things they do is they'll take a cup of water. They'll take energy and form a cup of water. Then you can drink that water, move the cup, whatever you want to do with it. That takes an enormous amount of energy. If you use Einstein's equation, energy is equal to mass times the speed of light squared. That means that to create a cup of water would take roughly 10 million megawatt hours. And to give you an idea of just how much energy that is, Commonwealth Edison, the utility in the Chicagoland area, the major utility, created 100 million megawatt hours in 1994. So they would have been able to make 10 cups of water. That's not an awful lot of material. If you're going to do that on a starship, you either have another method of making that water, or you've got an awful lot of energy available. Let's watch a video clip and see if the lights dim when they create that cup of water.
Computer, water.
Temperature.
12 arguments.
This system is calibrated to the Celsius metric system.
I need temperature at all on the cold side of whatever your system is.
So here we have it. In today, we'll have to rely on the magic of television to give us a cup of water, but who knows, in the future, maybe we'll be able to have science do just that. For the science behind science fiction, I'm Phil Winters. Thank you for watching.